All right, let's jump right in. We're talking about a massive shift happening in AI right now. It's this move away from building one single, giant, all-powerful model and into a whole new world, something that looks a lot more like a bustling, dynamic city of intelligent agents.
So here's the core idea, and it's super powerful. Instead of trying to build one single AI that's a genius at everything, the future is all about creating a team of highly specialized AIs that actually work together. Think less like a lone superbrain and way more like a high-performing company full of experts.
And this really shows you the two different ways of thinking. On one side, you've got the classic monolithic AI. That's a one huge model trying to do it all. And on the other side, you have the multi-agent system, or MAS, which is all about having a team of independent specialists that collaborate to get the job done. So, what exactly is a multi-agent system? Well, you can think of it as a collection of unique, intelligent agents. Each one has its own specific skills, and they all cooperate to solve problems that no single AI could ever hope to tackle on its own. And folks, this is the new frontier. Okay, so first up, let's get into the why. Why is this such a big deal? We're about to break down exactly what makes this whole team-based approach a fundamentally better way to build AI. The advantages here are just huge. I mean, first off, specialists are always going to be more accurate than generalists. It's way more scalable. You just add new agents to the team instead of having to rebuild the whole thing from scratch. It's also incredibly robust. If one agent fails, it doesn't bring down the entire system. And on top of all that, you get this massive speed boost from parallel processing. It's a game changer. And listen, this isn't just a theory. The numbers back it up. We're talking a staggering 37.6% increase in precision when you use specialized agents. That kind of leap in performance is just incredible, and it proves that a team of experts is always going to outperform a jack of all trades. But, okay, let's be real. If you've got all these autonomous agents running around, how in the world do you keep things from turning into total chaos? So next, we're going to dig into the critical rules you need to manage this AI metropolis safely and effectively. It really boils down to two key types of control. First, you've got agent-to-agent permissions. Think of these like job descriptions that define exactly what each agent is allowed to see and do. And second, you have dynamic guardrails, which are like the universal laws of the city, setting the ethical boundaries for absolutely everyone. So these A2A permissions, they actually work just like the access controls we use in human companies. Someone in finance can see financial data, but they can't access engineering source code. It's the exact same principle for AI agents. What they can do and see is strictly limited by their specific job function. And these permissions can get incredibly specific. For example, one agent might only have read access to some data. Another might be allowed to engage directly with users. And really high privilege actions like creating a new account, that's going to be super tightly controlled. You can even set rate limits to stop an agent from going haywire and overwhelming a system. It's all about having precise, granular control. So while permissions manage what individual agents do, you need something bigger to govern the entire system. And the source material for this explainer had this fantastic analogy, describing them as barriers on a mountain road. And that just perfectly captures the whole point of guardrails. You can really think of guardrails as the system's constitution. They are the high-level safety rules, the ethical framework that applies to every single agent in the system, no matter what its job is. This is what makes sure the entire AI metropolis is operating in line with the company's values and, just as important, in line with the law. Now, this all sounds pretty good in theory, right? But what happens when things go wrong? Let's dive into the dangers that might be lurking in this AI city, which really shows you why all those controls we just talked about are so absolutely vital. Probably the biggest wild card here is something called emergent behavior. This is when you get these complex, system-wide patterns that just sort of bubble up from the simple, individual actions of many different agents. The crazy thing is, these behaviors aren't programmed in. They just emerge. And they can be a really good thing or a really, really bad thing. You can see this duality all over the real world. On the good side, think about a flock of birds. Each bird is just following a few simple rules, but together they create this beautiful, complex, coordinated flight. But on the bad side, think of a phantom traffic jam. There's no accident, no stalled car, it's just a bunch of individual drivers hitting their brakes, and suddenly congestion appears out of nowhere. The exact same thing can happen with AI agents. The key to all of this is managing these risks before they become a problem. For every potential danger you can think of, from a hacked rogue agent to something insidious like data poisoning, there's a corresponding strategy. And it's all built on strong governance, constant monitoring, and, crucially, human oversight. It is a constant, careful balancing act. So when you weigh all the incredible potential against these very real risks, what's the blueprint? How do we build these AI cities of the future responsibly? Let's take a look at the path forward. To really build this future right, it's going to take a totally new mindset. First, we need this socio-technical model. That's a fancy way of saying we have to stop thinking we're just writing code. We're actually designing organizations of agents, which means legal and compliance teams have to be involved from day one. And second, humans have to stay in the loop, not to micromanage, but to be the ultimate deciders, using AI to make them better at their jobs. And what's going to allow all of this to scale are universal standards. We're seeing things like the A2A protocol emerge, which is basically a universal language so that agents from any company can talk to each other securely. And then you have the Model Context Protocol, which is like a universal data connector, giving agents safe access to real-time data so they're less likely to make stuff up. So, what are the big takeaways here? What's the playbook? Well, the path forward seems pretty clear. 1. Start small, but always plan for massive scale down the road. 2. Prioritize governance even more than you prioritize the code. That security and ethical framework is everything. 3. Treat this like you're designing an organization, not just a tech product. And finally, number 4, embrace those open standards to stay flexible and avoid getting locked in with one single vendor. And all of this leaves us with one final, pretty mind-blowing question to think about. As we assemble these complex teams of autonomous agents, and we govern them with rules, permissions, and even their own constitutions, are we still just programming computers? Or have we actually crossed a brand new threshold where what we're really doing is designing the very first artificial societies?